Okay, this is going to be section 1.4 notes on composition of functions. All right, so first we start with a quick review. We've been talking about functions, right, the last several sections. So up here we have three different functions, okay? This is f of x, and this one is g of x, and then the last one is h of x. So three different names, f, g, and h. Okay, so letter A says we want to find f of 2. Right? So that means we're going to plug a 2 into the f function. Well, which one is the f function? This one right here. So if I put a 2 in for x, I'm going to have 5 times 2, and then I still am supposed to add 2. So that's what it means to plug it in. Of course, if I want to do the math and simplify, it's going to come out to be 12. Again, I care less about the answer than knowing the setup. Okay, look at letter B. This time it says we want to plug 2 not into the f function, but we want to plug 2 into the g function. So that means I'm going to put the 2 into the g function. So that would be 3 times 2 and then minus 5. And again, if I want to do the math, that's going to come out to be 1. And then finally, this one it says, hey, this time we're going to plug 2 into which function? The h function. So I'm going to put the 2 into the h function. So that would be 3. In place of x, I put in a 2. I want to square that. So if I simplify, remember order of operations says you got to do the exponents first, right? So first we would have to square and get 4, then we can multiply by 3 and get 12. Okay, so function notation, like we've been talking about it. Now, the new thing for section 1.4 is called composition of functions. All right, and a composition of functions is when you have a function within a function. Okay, it's a function within a function. There's two different notations you might see. You might see this little circle, that means f of g, or you might just see an actual g of x, something like that, inside an f of x function. The second one is probably the more common actually in algebra. The only reason we even mention this notation is because sometimes it shows up on standardized tests. Okay, so my suggestion, if you see it, look at letter A. If you see it like this with the little circle, let's rewrite it in that second format. So the inside function is the g function. Okay, and on these composition of functions, my suggestion is always to start on the inside and work your way out. So in other words, since the g of x is on the inside, remember up at the top, g of x was 3x minus 5. So really what we're saying here is f of, what is g of x? Well, g of x is 3x minus 5. Okay, so now what does that mean to have 3x minus 5 in there? Well, doesn't that mean you take whatever's in the parenthesis and plug all of it into, in this case, the f function? So I'm going to take the entire parenthesis, 3x minus 5, and I'm going to plug it into the f function. Okay, remember the f function is 5x plus 2. So I'm going to have 5 times, in place of that x, I'm going to put in the entire parenthesis, 3x minus 5. And then don't forget you still have your plus 2. Now again, I can do the math, but that right there is the most important part of this problem. In fact, for now, I'm not even going to mess with that because I don't want to get bogged down in the simplifying part. I want to make sure you understand what composition of function looks like. Okay, so on the next one, notice the outside function is the g, but do you see the inside function is the f? Well, from up above, the f of x is 5x plus 2, right? Okay, so now step back and look at it. What does that mean? That means take the entire 5x plus 2, put it into the g function everywhere you see an x. Well, remember, g of x was 3x minus 5. So I'm going to have 3 in place of x. I'm going to put 5x plus 2. But then don't forget at the end of the g of x, you have your minus 5. Again, you could, distribute, subtract, whatever. But I don't want us to get bogged down with the detail right now. I want to make sure we understand the setup. Okay, so for the last one here, I'm going to rewrite it without that little circle thing. So I've got f of, and this time the inside function is the h of x, right? And so what that means is I'm going to have f of, well, what was h again? H was 3x squared. 3x squared. Okay, so now I'm going to take that entire parenthesis, that 3x squared, and put it into the f function. So the 5x plus 2, so I'm going to have 5. In place of the x, I'm going to put in 3x squared. And then don't forget at the end, you have the plus 2. Okay, so keep in mind, this is the most important part of each one of these, right? That shows the setup. That shows me that you understand the composition of functions. Yes, you need to know how to simplify it. You need to know that if you distribute the 5, you're going to have 15x minus 25 plus 2, and that's going to turn into 15x minus 23. Yeah, don't get me wrong. I want you to know that, but I want you to understand the setup more than anything. Okay? So I'm going to do this just to kind of bring them down here. Remember up at the top, we were given f of x to be 5x plus 2. I'm just kind of writing them down here. We were given g of x to be 3x minus 5. And we were given h of x to be 3x squared. Right? All of that we were given at the very top of the page. This we're going to use all the way down. Okay? This we're going to use. Boom. Just so I don't have to kind of be scrolling back and forth. All right. So look at number 3. Remember that little circle, what that means is f of g of, but this time it's not of x, it's of 2. Okay? So let's start with what is g of 2? Well, g of 2 means if I plug a 2 into the g function right here, hey, if I plug a 2 in for x, won't that be 6 minus 5, which is 1? So what I'm saying is g of 2 is 1, right? So if there's numbers, go ahead and plug in the numbers. So now I'm trying to figure out, well, what is f of 1? Well, if I plug a 1 into the f function, here it is. If I plug a 1 into the f function, wouldn't that just be 5 times 1? 5 plus 2 is 7. I like these better where there's, instead of x's, where you have numbers, because you get kind of a nice, neat answer. Okay, so let's look at the next one. I'm going to have g of, well, let's start with f of 1. Well, if I plug in a 1 for f, we already said that's going to be 7, right? So f of 1 is 7. Okay, so now work your way out. We're still kind of starting on the inside, working our way out. So now let's plug 7 into g. Here's g. So 3 times 7 is 21, minus 5 is 16. Okay, and look at the last one. Start on the inside and work your way out. So what is h of 4? H of 4. So go to the h function. There it is, right? If I put in a 4, first I have 4 squared, which is 16, and then that's going to be multiplied by 3, so that's 48. So h of 4 is 48. Okay, and now I'm supposed to put that 48 into the f function. Remember, f was 5 times x, so I'm going to have 5 times 48 and then plus 2. Okay, yeah, I know that's a bit of a pain. Let's see, that's going to, 5 times 40 is 200. 5 times 8 is 40, so that's going to be 240 plus 2. You can check the math if you want to, but that's the idea. Okay, so we're still working with different kinds of properties of functions. Now, I've got 2 different graphs, okay? Notice the f graph is this one, okay? You see it all along, and then the g graph is this one that's kind of linear, okay? So letter A, I want f plus g. Okay, there's a plus. That's not the little circle. That's not composition. Okay, what this means, and this is kind of an ACT, SAT thing also, this is the same as saying f of -1 plus g of -1. Okay, now let's go up to our graph and figure out, well, what is f of -1? Well, that means if you look on the f graph, okay, so that's this one I've got started in blue, go to where x equals -1, x equals -1. Where does that hit the f graph? Right there. Okay, and so the y value on that is -2. Okay, so now if we look at the g graph, go to the g graph. Go to where x equals -1. Where does that hit the g graph? Well, I think that hits right here at +1, right? And then you can do the math, and that comes out to equal -1. Okay, look at letter B. Now, don't get this confused. That little dot right there, that's not the circle that we were using above for composition. That's multiplication. So this is saying, what is f of 4 times g of 4? Don't get that confused with f of g of 4, okay? They are not the same thing. Not the same thing. Okay? So for this one, well, how am I going to find f of 4? Go to where x equals 4. See where that hits the f graph. This is the f graph right here. That hits at 3. Okay, and then if I want g of 4, go to where x is 4. Where does that hit the g graph? That hits right here at 1. So 3 times 1 is 3. Okay? You guessed it, for letter C, what would you speculate that notation means? That subtraction means f of -2 minus g of -2. Okay, so find where x is -2. X is -2. Where does that hit the f graph? It actually hits both the f and the g at the same place, right, at -1. So f of -2 is -1, but g of -2 is -1. Notice there is a minus sign between them. What's this going to come out to equal? Oh, look. Minus and negative means plus. So what is -1 and +1? Doesn't that come out to be 0? Okay, so letter D, is that multiplication or is that composition? And I'm hoping you're saying, oh, that's composition, right? So start on the inside. What is g of 6? Well, here's where x equals 6. Go up. Where does that hit the g graph? Right here. Hits the g graph at -1. So we're saying this part, g of -6, is -1. But isn't that still inside of that f? Okay, so now what is f of -1? Well, go to where x is -1. Where does that hit the f graph? We already found that one. That hits at -2. I definitely like these ones with the graph more because there's less computation. It's a matter of just looking at the graph. Okay, letter E. Now there's that circle that means composition. So that means g of f of 4, right? So we're going to start with this part, f of 4. So go up to the graph. Go to where x equals 4. Where does that hit the f graph? We found that one up here, the blue. That's 3. So this inside part is 3, but you still have this g on the outside. So now to find g of 3, go to where x is 3. Where does that hit the g graph? Well, it actually hits both of them at the same place, right there at 2. Okay? And then I look at letter F. Oh no, is it okay to have the same letter? Yeah, it's fine. But again, you still start on the inside. Does that mean the answer is just 0? No, not necessarily at all. It could be, but not necessarily. It would be a coincidence if it was. So start on the inside. What is g of 0? So go to where x is 0. Where does that hit the g graph? That hits right here at 3. So that means this inside part is 3, but I still have this g on the outside. Okay, so now what is g of 3? Well, go to 3. G of 3 is 2. Okay, so that's section 1.4 on composition of functions.